All right, guys, so in this video, we are going to take a look at more complicated integration problems. And so when things start getting complicated with integration, we're going to use a process called U substitution. In case you haven't realized yet, there's no such thing as a product rule or a quotient rule or a chain rule when it comes to integration. And so when things get complicated, like the examples that we're going to see today, we use a process called U substitution. If you were to take a higher level calculus, you would get into integration by parts and several other more complicated methods, but we're going to stop this class with U substitution, okay? So I've written a hint down on the screen. The hint says we're going to consider U as the inside piece. And then, of course, what does du mean? Du will be the derivative of U, so the derivative of the inside. So we've got three problems we're going to look at today, and I tried to give you a simple problem, a medium problem, and then a more complicated problem. So the first problem we're going to look at is number 1. Number 1 states we're going to take the integral of 3x squared times x cubed plus 4 to the 7th power with respect to x, okay? And so to start, guys, you need to figure out what u is, okay? To make it more simple, we need to use substitution, which means we need to figure out what u is. And if you think about u as the inside piece, hopefully, most of you can recognize that the inside piece is x cubed plus 4. And so I'm going to write x cubed plus 4 right here. The next step I expect most of you to be pretty good at, the derivative of u. Well, the derivative of x cubed is 3x squared. And you learned that the derivative of a constant is 0, which means the derivative is just 3x squared. However, we are taking the derivative of u with respect to x, which means we need to tack on a dx. Okay? And so there's some of the problem. Now, I'm going to rewrite this just to make it a little bit more simple for some of you. If I bring the x cubed plus 4 to the 7th power to the front and the 3x squared dx to the back, this is just so you can see it a little bit easier. Hopefully now you recognize that x cubed plus 4 is u. So that's going to be u to the 7th power. And 3x squared dx, guys, 3x squared dx is simply du. So I can write du. So now that we have changed this thing from something complicated with a whole bunch of x's to something way more simple with u's, okay? And you can only take the integral of u du when you only have u. So we only have u's there, so that's good. For example, if you would have had a u and an x right here where I'm underlining, then you have done something wrong, okay? So if we take the antiderivative of u to the 7th, remember antiderivatives, we add 1 to the exponent. So it'll be u to the 8th divided by 8. And because I didn't give you a lower nor a upper bound, a lower bound or an upper bound, then remember that means we put a plus c. And the last step is the easiest step, guys. So you have done the hard part. The last part is to reverse the substitution. So what was u? U was x cubed plus 4. And so we're going to write x cubed plus 4 to the 8th power divided by 8. And then, of course, tack on that plus c. And there's our final answer for the very first one. Okay? If you noticed, everything turned out real pretty. U fit perfectly into the problem. Our du fit perfectly into the problem. As long as you picked the correct u, the problem was pretty simple. Okay? So if I roll down to number 2 now. Number 2, some students are a little bit more intimidated because it's a fraction. And they don't know how to pick u when there's a fraction. So my hint is, when there's a fraction, I would start with the denominator, okay? I'm not saying it's always the denominator, but sometimes, okay? So if I pick u to be the denominator, u will be 1 plus x squared. And then the derivative of u, the derivative of 1, again, is 0, and the derivative of x squared is 2x. Again, we're taking the derivative with respect to x, so tack on a dx. And now you can clearly see that the numerator, 2x dx, is simply du. And the denominator, 1 plus x squared, is simply u. And in my heart, I'm like, oh yeah, I'm doing this right because now I only have u's in my problem, which is good. Up here I had x's. Now I have u's. So I have made it less not more complicated, less complicated. I like to rewrite this as 1 over u times du. Hopefully most of you are strong enough algebraically to know that these two things mean exactly the same. And why do I like to rewrite that? Because I know that the antiderivative of 1 over u is natural log of u. Okay? I need you to know that from 4.1. So the antiderivative of 1 over u is the natural log of u plus c. Okay? Why plus c? Because I didn't give you a lower bound nor an upper bound again. Okay? And then what is the last step? The last step is simply to plug back in u. And what is u? The natural log of u will be the natural log of 1 plus x squared plus c. And then I need to mention as well, remember, if I don't tell you that x is greater than 0, you have to put absolute value bars with the natural log. So I'm going to go back and put not natural logs, but absolute value bars around there. Okay? And so that right there is my final answer. Okay? And then if I take a look at the last problem, number 3, and if you take a look, I try to give you problems like pretty simple polynomial. This one had a natural log in it. This one has an e in it. So I'm trying to give you examples that kind of build. So when you take a look at this one, I'm going to let u be the exponent. Okay? So if u is the exponent, u is x squared. Okay? And then the derivative of u is going to be 2x with respect to x. Okay? So if I rewrite this problem and change the order up again so you can see it a little bit better, this is e to the x squared x dx. Okay? So hopefully you recognize that I can write e no longer to the x squared because x squared is u dx. So I'm just going to write a u. And here's the problem. Here is the problem. In order to write du, guys, I have to have a 2x dx. You can clearly see I don't have a 2x dx. All I have is an x dx, which means I need to put a 2 into the problem. Okay, so I am multiplying a 2 into the problem, 2x dx. Because you can't just multiply a 2 into a problem because you feel like it. So on the outside, you need to multiply by something that undoes 2. So what undoes 2? Most of you are probably ready to realize it's 1/2. 1/2 times 2 is an imaginary 1. And the original problem had an imaginary 1. Okay? So that means I need to put a 1/2 down here. And now that I have a 2x dx, and I can write 2x dx because I put the 1/2 on the outside, now I can write du. Okay, so again, why do I have a 1/2 on the outside? I have a 1/2 on the outside to undo the 2 that I multiplied into the inside. Why did I have to multiply a 2? Because in order to write du, I had to have a 2. So this one wasn't one that turned out so pretty is what I was telling you. But from here on, it is very easy. And the reason it's very easy is 1/2 stays on the outside. When we integrate, or when we take the antiderivative of e to the u, the derivative and the antiderivative of e to the u is just e to the u. Okay? And then we're going to add our plus c. And so it'll be 1/2 e to the u plus c. And then what's the last step? The last step, of course, is to reverse the substitution. And u was x squared, so plug in an x squared for u, plus c. And there's your final answer, guys. Okay? So I hope all of these examples help.